Okay, another implicit differentiation, number 7 on section 3.7. And this is x plus the tangent of xy equals 0. So again, we take the derivative implicitly. So the derivative of x is just 1 dx dx plus the derivative of the tangent. Now remember, the derivative of the tangent of something, this is a chain rule issue, is the secant squared of that something times the derivative of the something. So this is my inside function here. Okay? I really could have highlighted that, so it'd be a little bit easier for you to see. So this is my inside function here. So I have to take the derivative of that, all right? So this is the tangent of something equals the secant squared of that something. So remember, take the derivative of the outside function, which is the tangent, evaluate it at the inside function, times the derivative of the inside function. So again, this is consistent with the chain rule, inside-outside rule we talked about. Okay. So the dx over dx is just 1, or that's just 1. Okay. The derivative of x with respect to x is 1. And remember, we write everything to the left of the dx as, and we have to take the derivative of what's to the right of the dx. Okay, the ddx, I should say. And this is going to be the product rule, so it's going to be the first times the derivative of the second, which is dy dx, plus the second y times the derivative of the first, which is dx dx, which is just 1, equals 0. And I just made this 1, so I took an extra step to do that. And I remember, you'll see this a lot, so remember to kind of isolate this as an entity and take that derivative. Okay? All right, and then again, we're trying to isolate the dy dx, so we have to get at it. It's in this bracket. I've got a 1 here. Now, this is not a binomial. This is 1 times this whole thing. This is not a parenthesis, so don't do that. Okay, this is 1, and then I've got to multiply this times each of these terms. So the secant squared of x, y times x dx is this term here. So this is just this. So when I multiply secant squared x times x dx, this is what I get. And then when I multiply secant squared x, y, secant squared xy times y, I get secant squared xy times y. So that was just using the distributive property like that. So I had 2 multiplications, and then I've got the 1 out in front. So keep that in mind. And then again, I want to isolate my dy dx term. I only have 1 of those, so everything else goes on the right. So the 1 goes on the right, becomes a negative, and the secant squared xy y goes on the right. And I just had this time put the y in front as I moved it. And then I want to solve for just my dy dx. I'll have to divide by this. So I divide both sides by x secant squared xy. So this goes on the bottom. So b over 1 goes on the bottom. Okay, so that's kind of a raw form of the answer. We'd like to simplify a little bit, which we can. So I could break this up into 2 fractions, a negative 1 over x secant squared xy minus, this is my negative sign, y secant squared xy over x secant squared xy, because these are the same, so that's going to be a 1. And then I could always rewrite this, because I could write this as 1 over x times 1 over the secant squared of xy. That's the same thing. And 1 over the secant squared of xy is the cosine squared of xy. In other words, if 1 over the secant is the cosine, 1 over the secant squared is the cosine squared. So I have a negative 1 over x cosine squared of xy. And then these are just 1. Secant squared xy over secant squared of xy is 1. Just 1's out, so this is what we have. Y over x. So that's all there was to that. Okay. And let's take a look at number 9. So here's number 9. And what we want to do is find the derivative dy dx, and then also find the value of the slope at the given point. Okay. So find the slope at the given point, and the point was at negative 2, 3. So I take the derivative. This is implicit again. Actually, it's a kind of a circle, so let's take that derivative. So we've got 2x dx dx plus 2y dy dx, and the derivative is 13 is 0. And the dx is just 1, so that's just 1, and then I can subtract that from both sides, so I can isolate my dy dx terms. And then I divide both sides by 2y, and dy dx equals negative 2x divided by 2y. And the 2 over 2 is 1, so I just have negative xy. And then if we want to evaluate that, dy dx at the point negative 2, 3, then there's a negative, and then x is negative 2, and y is 3. And a negative times a negative is positive, so I just have 2/3. That was your solution. Or your slope at that point, negative 2, 3. On that curve, which is actually a circle there. Okay? And then number 11, one more evaluating, finding the slope at a point. And the point in this case was 3, 4. And it's under the circle, it just happens to have a shift, or the vertex, the center is shifted. So this is x minus 1 squared plus y minus 1 squared equals 13 at this point, 3, 4. So first of all, let's define dy dx, so we take the derivative. So we've got 2, so this is something squared, so this is 2 times something to the first power times the derivative of the something, and the derivative of just x. Well, the derivative is negative 1 is 0, and the derivative of x is just 1 dx dx. Then I take the derivative of this, something squared, that's going to be 2 times the something to the first power, times the derivative of the something. So my inside term is this, and the derivative of that is just going to be 1 dy dx. So I might have skipped a minor step there. Okay? Then we want to isolate the dy dx. Now this is just 1, so I don't need this anymore, so I could just kind of block that out. So I'll subtract that term from both sides, so I've got negative 2 times x minus 1 on the right. Just move this on the right. So we can isolate our dy dx term, and then I divide both sides by 2, y minus 1. So dy dx equals negative 2 x minus 1 all over 2 times y minus 1. The 2 over 2 is 1, so I just end up with negative x minus 1 over y minus 1. All right. And then they want to find that derivative, so they want us to evaluate that. Okay, at the point 3, 4, so we'll put 3 and 4 in for the x and y. So I had negative, and then x was 3 minus 1, and y was 4 minus 1. Well, that's going to be negative, and then 3 minus 1 is 2, and 4 minus 1 is 3, and you're done. Okay, so that's number 11. There's your derivative, and there's your slope at that point, 3.